Hello Anti-Matrix, welcome to your first lesson of AP for 2021. Our first section is not a particularly long section, it's going to really just take until the end of this week. Alright, but it's the beginning of calculus. Now calculus effectively is the study of motion in mathematics. And it deals with a lot of gradients of straight lines, of different curves at certain points, but really it's the mathematics of motion. Okay, so the first thing we're going to look at is what's known as the upper and lower sum approximations. Okay, now you haven't done any calculus in core maths yet. You will, through the course of this year in AP Maths, do quite a bit of calculus, but this is really just a very, very, very introductory lesson to a concept which is going to be developed later on a lot more. Alright, now what the upper and lower sum approximations do is they help us to find the area of a particular region. Now if you think of a square or a rectangle or a circle, and I give you that object and I ask you to find the area of that, it's fairly easy because you've got formulas for it. Alright, why do you have formulas for shapes like rectangles and squares and circles? Because those are regular shapes. We know for a rectangle it's the length times the breadth. We know for a circle it's pi times the radius squared. Alright, but when the shape is not regular, particularly when one of the edges of the shape are curved, and it then makes it a little bit more difficult to find out the area. So if you look at this diagram, this is the graph of f of x is equal to x squared plus 1. Alright, so it's a parabola, and with a parabola we know that the gradient is not the same throughout the parabola. I mean, here at the origin, the gradient is actually 0, because that's the turning point of the parabola. Alright, here the gradient was decreasing, and here the gradient is increasing, so it means it's 0 there. The gradient of the graph in this region is much steeper than the gradient of the graph in this region. So effectively what I'm trying to say is that it's not regular. Right? There isn't just one formula that can help us work out the area. Alright, but say now that I wanted you to work out the area of this graph between x is 0 and x is 4. What is the area that is formed between the x-axis, the graph, and the x values of 0 and 4. Okay, so if I had to highlight that region, we would have the x-axis highlighted here up until 4. Then this all includes up until x equals 4. And then we would go along the curve. Okay, so effectively, we're looking for the area of this region that is shaded in green. Okay, but like I said, it's a little difficult to work out that area with the formula alone because of the fact that it's irregular. So we want to develop a way that we can work out the area of any curve, not just this parabola. It can be any function. The area that is created between that function, the x-axis, and two x value boundaries. Okay, when I talk about the x value boundaries, I'm talking about the vertical maximum of x, in this case x equals 4, and the vertical minimum of x equals 0. Alright, so let's look at a method that we can do this. Okay, so I'm going to take away my shading, and we're going to start with something different. Alright, what we're going to start off by doing is to draw rectangles that are of equal width. Okay, and I'm going to help you to do that. And why rectangles? Because rectangles are regular shapes that we can work out the area quite easily of. Okay, so I'm going to pause quickly and then I'm going to draw the rectangles and then I'll carry on talking about it. Alright, and so here are my 4 rectangles that I've drawn, just to point out a little bit what we are doing. Okay, now I started off this lesson telling you it's upper and lower sum. This is known as an upper sum. Okay, and the reason for that is because look where the rectangle's drawn. I've started, look where the rectangle meets the graph. In each case, the rectangle meets the graph at the x value at the bottom here. Okay, so the first time the rectangle meets the graph is at x equals 1. And then there's this portion above the graph, which we don't actually want the area of. Okay, but we're going to get to that now. This value here, where x equals 2, meets the graph. And then there's this portion to the left that's above the graph. That's where the upper comes in. Okay, because that upper part is what we actually want to try and eliminate. Same for the 3. Where the 3 meets the graph, we have a portion above. Where the 4 meets the graph, we have the portion above. Okay, so just to highlight quickly, where do we actually want the area? We want this area. Okay, we want the blue area. All right, we do not want the area above. So in other words, we don't want this area as part of our approximation. We don't want that area, we don't want that area, and we don't want that area. Okay, however, when we work out the area of each of these rectangles, we're going to get the combined area of the red and of the blue. All right, let me show you what I mean. All right, so now we're going to take the area of each of these rectangles. Okay, but in order to determine the area, we actually need to know their dimensions. All right, they are all equal in their width. Okay, all of their dimensions, I'm going to use another color here. Let's use pink, is 1 unit. Sorry, let me just use the correct pen. Okay, so that's 1 unit, this is 1 unit, that's 1 unit, and that's 1 unit. Now for their heights, to get the corresponding height, effectively the height is the y value at this point, isn't it? Okay, the height of the big rectangle will be the y value at this point. The height of the next rectangle will be the y value at that point, and so on. All right, and in order to get those y values, we've got to substitute this corresponding x value into that equation to get the y value. All right, so let's start. All right, so firstly, when x is 4, then f of 4 will equal 4 squared plus 1, which equals 16 plus 1, which is 17. All right, so it means then that the height of this first rectangle is 17 units. All right, and then let's look at the second rectangle. So the second rectangle is when x is 3, and we're wanting to find the y value at that point, which would be the height. All right, so f of 3 is equal to 3 squared plus 1, which is 10. So the y value of this portion is equal to 10. Okay, and remember that just means this height here. Okay, not the whole height. We're looking at the second rectangle from the right now. All right, then we can look at the next rectangle. So when x is 2, then f of 2 is equal to 2 squared plus 1, which is 5. So the height of this portion is 5. And then lastly, we can look when the x value is 1. So f of 1 is equal to 1 squared plus 1, which is 2. All right, so the height of the last rectangle then is 2 units. Okay, so what does this mean? This means that we can now work out the areas of each of these rectangles. Okay, so the areas of the total 4 rectangles would be given, and I'm going to just move down a bit. Area would be given as, I'm working now from the left, okay? So we're going to look at this rectangle first. So the length is 1, or at least the breadth is 1, times the height is 3. Sorry, 2, not 3. So the first length, the first area at least, is going to be 1 times 2, plus the second rectangle will be 1 times 5, plus the third rectangle will be 1 times 10, and the fourth rectangle will be 1 times 17. All right, so if we add all of those together, we get a area of 34 units squared. All right, but now let's look at the problem here. Okay. Right, now using software, I can tell you that the actual area of the region that we want, and remember that is the region that is below the red curve and bounded by x equals 4 and x equals 0. So the actual area of that blue curve is equal to 25,33 units squared. Okay, but why are we getting a much bigger area of 34? Okay, that's because with our calculations here, it included these triangles that are above, or kind of triangles, okay, that are above the curve. So we need to work out a way to eliminate those triangles, all right? The more we can eliminate those triangles, the closer we'll get to our desired answer of 25,33. All right, so let's remember our first attempt was 34. We want to get closer to 25. Okay, so what I'm going to do is I'm going to erase this now. We're going to come back and work it out using a different method. Well, not a different method, but a more refined method. And I'm also going back to the drawing board here, and I'm going to erase the notations that I've made. Okay, so let's erase all of that. And remember, we started off with 4 rectangles. So we're still going to use the same curve, x squared plus 1. But this time, instead of 4 rectangles, we're going to divide it up into 8 rectangles. All right, so I'm going to pause while I draw those rectangles, and then I will carry on explaining. All right, so here you have 8 rectangles. So it's still exactly the same area. It's still from 0 to 4. But instead of dividing the shape into 4 rectangles, I've doubled that and divided it into 8 rectangles. Okay, so what that does is it changes the width. So each width now is going to be 0,5. All right, and then we can still, the same way, work out the corresponding heights of each triangle. So the first triangle, I'm just going to write them. I'm not going to show you the calculations. Remember, each time we're still just substituting it into this equation to work out the corresponding height. The first one is still going to be the same as in the previous one because it's the same height. So that was 17. Now the next one in the half, which was halfway between 3 and 4, is actually 6,625. Sorry, not 6,625, that's actually the area. I'm jumping the gun. But the length is actually 13,25. Okay, and then the next length is 10. That's the same one as we worked out in the previous one. The next length is 7,25, also the halfway between 2 and 3. Then the next length is 5. We worked that out in the previous one. Then the next length is 3,25. The next length we worked out was 2. The next length is 1,25. And there we have all the information needed for the areas now. Okay, so to work out the area now of this curve, we're going to say the area is equal to, now I'm starting from the left again, a half times 1,25. That's the first rectangle, plus the second rectangle, this is going to be long, is a half times 2, plus a half times 3,25, plus a half times 5, going to the next line, plus a half times 7,25, plus a half times 10, plus a half times 13,25, plus a half times 17. All right, and that in total, once we add those all up, gives us 29.5 units squared. Okay, so let's analyze this now. The ideal answer, remember the one that I told you is the actual answer, was 25,3 recurring. The first time we got 34, now we've got 29.5. Can you see that we're getting closer? And that's because the more rectangles we have, the smaller the excess area is going to be. Okay, even though there are more of them now, they're much smaller. All right, and the more rectangles we end up having, you'll see that the closer we get to the actual answer. Okay, so if you turn in your textbook, if you have your textbooks, to page 225, I'll put the diagram up if you don't have your textbooks yet, but 225 in your purple textbook, your algebra and calculus textbook, there's an Excel table there. Okay, so this is the Excel table that is on page 225 of your textbook. let me explain to you what is happening. So in the first column here, we have n. Now, n represents the number of rectangles. All right, and then u of n represents the upper sum of n rectangles. All that means is that 34 represents the area of those 4 rectangles combined. Okay, but the margin of error is actually quite big. It was 8,6667 or 8,6 recurring. Okay, and what that means is that that's how far off we are from the correct actual exact answer. Okay, and as we just saw now, if we used 8 rectangles, so we divided the region from 0 to 4 up into 8, we got an area of 29.5. So every time what's happening here is the number of rectangles is doubling, because each rectangle then we're effectively halving again. So we end up with 16, 32, 64, and obviously we're not going to work them out any further because it gets too tedious. But you can see that as the rectangles get more, until we eventually get to 8,388,608 rectangles, we end up with the exact area of 25,3333, and the margin of error is 0,0000. Okay, so almost exact. Now, why I say almost exact is because if we saw more decimal places here, you'd probably find that there still is some margin of error. Okay, because although these rectangles are extremely small, there would still be a small part of the rectangle that's above the curve for each one of them. Really, really, really small, but it would be there. Okay, right, so the important conclusion here is, notice that as the number of rectangles are increased, the upper sum approximations decrease in value. That's what was happening here, and approach the actual area of 25,3 units squared. Okay, so that last example was an upper sum approximation, both of those examples, because in each case that little extra bit of area that we didn't want was above the curve. Now we're going to look at lower sum approximations. Okay, and we're going to use exactly the same diagram, except the difference is going to be that we're now going to draw our rectangles almost exclusively below the curve. Okay, so I'm going to pause and draw the rectangles, and then I'll explain them. Alright, so I've drawn my rectangles. Notice now that the point where each rectangle's height touches the curve is now to the left of each rectangle. Okay, so if we look at the big rectangle, where it's meeting the curve is there. You might remember in the upper approximation, it was over here, in fact, and then we drew the rectangle like that. So it was a much bigger rectangle. And now the second rectangle is meeting to the left, and the third, etc. And the last one is meeting at the y-axis. Okay, so what that means is that now when we work out the areas, we're actually going to be working out these areas that I'm highlighting in blue. Okay, which means that our total area is actually going to be less than what we want, because we also actually want this area, but it's not going to give us that area. Okay, so effectively we're going to be approximating, but from the other side of the actual area. Okay, remember before with the first one with 4 rectangles, we got an area of 34, but we wanted 25,3. Okay, so we got an area that was much bigger. Now we're going to get an area with 4 rectangles that's much less than 25,3 because we've got a lower approximation. Alright, remember the curve is the same curve, f of x equals x squared plus 1. And we're going to work out the values of the lengths and breadths of each of these rectangles. So the breadth is still the same. The width is equal to 1 in each case. Now for the heights, now look carefully. Instead of substituting 4, we're not going to substitute 4 into the equation, because if we look at the height where x is equal to 4, it's not on the curve. We're going to start with 3. Okay, that's the first part of the rectangle that's on the curve. So when x is 3, we have f of 3 is equal to 3 squared plus 1, which is 10. Okay, so this distance here is equal to 10 units. Okay, then we're going to go to x is 2, sorry. So when x is 2, we've got 2 squared plus 1, which equals 5. So this distance here is 5. Alright, and then the next one we're going to go to is when x is 1. So when x is 1, f of 1 is equal to 1 squared plus 1, which is 2. Okay, so this height here is 2. And then lastly, we're going to look at when f of x is 0, when x is 0. Okay, so when x is 0, we end up with 0 squared plus 1, which is just 1. Okay, so the area of all 4 rectangles together then is equal to, let's start with the small rectangle. This will be 1 times 1. Okay, 1 times 1 plus the next rectangle is 2 times 1 plus 5 times 1 plus 10 times 1. Okay, so that's effectively 1 plus 2 plus 5 plus 10, which is 18 units in total. All right, and then similarly, if you had to divide the shape into 8 rectangles, and you can look at the Excel spreadsheet, I'm not going to put them in, I'm not going to put it on the diagram, but on the video, but the Excel spreadsheet on page 227 shows us that when we use 4 rectangles, we get 18 as an area. When we use 8 rectangles, we go to 21.5, and as the number of rectangles increase, we get closer and closer to the value of 25,333, which is the value that we want.